evaluate the integral x squared times the square root of 3 plus 2x minus x squared dx. Notice that most of the trigonometric substitution integrals involve the binomials a squared minus another squared. One is a variable and another is a constant. Inside, the radical is now a trinomial, so first we will need to complete the squared. To complete the squared, keep in mind that a plus b squared is a squared plus 2ab plus b squared. To turn a trinomial into a complete squared, a squared of a binomial, we would need twice the product of the first and the last. The square root of a minus b is a squared minus 2ab plus b squared. Thus, to complete the squared for 3 plus 2x minus x squared, we first rewrite this at minus x squared plus 2x plus 3, and we're going to factor out the minus 1 times x squared minus 2x minus 3. But to complete the squared, we would need the third term squared minus twice the product of the first and the second, but we only have 2x, so we forced to multiply 1. That means the second terms in the squared has to be 1 squared. But 1 squared is split from negative 3. To obtain negative 3 back, we will need to subtract 4. Simplifying this, we have minus 1 times x squared minus 2x plus 1 squared. And then negative 1 times negative 4 is plus 4. This is now minus 1 x minus 1, the quantity squared, plus 4, or 4 minus x minus 1 squared. This is 2 squared minus x minus 1 squared, which is of the form a squared minus x squared, where the x term, the variable term, is now x minus 1. We should always double check to make sure that we completed the square correctly. X minus 1 squared is x squared minus 2x plus 1. And so 2 squared minus x minus 1 squared is 4 minus the quantity x squared minus 2x plus 1. 4 minus 1 is 3. Negative 2x is positive 2x, and negative x squared. The given integral is now the integral of x squared times the square root of 4 minus x minus 1 squared dx, which is of the form a squared minus x squared, where a is 2 and again x is now the expression x minus 1. And so we let the variable term x minus 1 equals a sine theta, but a is 2. Not x equals 2 sine theta, but x minus 1, which is the expression inside the squared. X is therefore 1 plus 2 sine theta. Dx is 2 cosine theta, d theta. So we have a substitution for dx. Also, x squared is 1 plus 2 sine theta squared, or 1 plus 4 sine theta plus 4 sine squared theta. We still need a substitution for 3 plus 2x minus x squared, but this is 2 squared minus x minus 1 squared, which is 2 squared, minus x minus 1 is now 2 sine theta. Factor out the 2 squared, we have 1 minus sine squared theta, but 1 minus sine squared theta is cosine squared theta. Keep in mind that 3 plus 2x minus x squared is underneath the radical. And so when we find a substitution expression for the square root of 3 plus 2x minus x squared, we would use 2 cosine theta. We don't need to worry about the plus or minus when we take the square root, because with the proper restricted domain, the sign will be taken care of. The trig substitution for the integral of x squared times the square root of 3 plus 2x minus x squared dx is now the integral x squared is being replaced with 1 plus 4 sine theta plus 4 sine squared theta. The square root of 3 plus 2x minus x squared is being replaced by 2 cosine theta, and the dx is being replaced with 2 cosine theta d theta. We now need to find the antiderivative of this trigonometric expression, which is the trig substitutions of the given integral. This is now 4 times the integral of cosine squared theta plus 4 cosine squared theta sine theta plus 4 cosine squared theta sine squared theta d theta. 2 times 2 is a factor of 4, so we move the factor 4 in the front of the integral sign. We then integrate each term separately. Using the double half angle formula for cosine of theta, we can reduce the power of cosine of theta. Cosine squared of theta can be rewritten as 1/2 times the quantity of 1 plus cosine of 2 theta. There is an odd power of sine theta in the second term, so we will use substitution. Let u be cosine of theta, then du is sine of theta. For the third term, both of the factors have even power, so we will need to use the double or half angle formula for both cosine and sine and multiply them out. If the question asks us to rewrite the given integral in the form of trig integrals and simplifying this, we will stop right here. If we were to finish the problem, we would just simply use trigonometric integrals, follow the guideline from trigonometric integrals to obtain the answer.